this video, we will discuss another PLC programming language, which is BASIC. In the previous video, we have discussed about ladder logic, which is a graphical language. BASIC is a text language. The advantage of ladder logic is that you have a visibility on digital state that you don't have with the BASIC language because it's a text. The advantage of BASIC is that it might be easier for programming because you just type text and you don't require any mouse activity, and maybe also because it accesses many more functions, like for instance all the functions associated to text is not available in ladder logic but in BASIC. A process can be divided into piece of ladder logic and piece in BASIC according to the needs. This is what we will do now. We will keep this part in ladder logic and we will do another part with BASIC code. And for that, we will simulate our process. So remember, we have our water tower, our water distribution network. We will simulate activity here. We will simulate the tank filling in and emptying. We will simulate activity on the valve with different flows. We will simulate pump activity. Okay, for this we will define a basic program to simulate this process. Let's first take a look to the variables and the tags that we need. So we need valves, we need flows going through the valves, we need the pump, and we need the level of the water tower. So in terms of tags, if I go to the IOs, I already have the valve and the pump, which are outputs. The water level is an analog input, but I don't want to use this one because I want myself to simulate the level in the tank. I don't want this to be associated to a physical input. So I will have to make a new variable, which I will call, let's say, water tank, which will be an analog tag format float. And this tag I will increment, decrement to simulate my activity in my water distribution network. The flows, they are available here. So in terms of tags, I have everything. Now I will create a new POU with this time the language BASIC, and I will call it, for instance, water. Okay, let's double click this POU and we are in BASIC edition. My first line will be a command. To insert a command, you use the single quote and you type a text. For instance, simulation of a water distribution network. Okay, so you can put several lines with a single quote. Then I will need in my process to have a random value because I want the flow to be random, to simulate an activity in my flow. So for this I will use timers and I will use the value of the timers. And for that I will reactivate permanently a timer and I will use its value. So to permanently activate a timer, to re-trigger permanently a timer, if I look to the chart of a timer, when the timer is activated, it starts running. This is the value I will use to compute my random value. You see, when TBox starts, the state is always at 0. So if I use the inverted status of the state as activation, when the TBox starts, my timer will automatically start running. As my timer starts running, the digital state changes to 1, but I use the invert to activate my timer. So at that moment, my activation will be to 0. So my timer goes until the end, and at the end, when my timer finishes, the state returns to 0, and as the state is used as activation of my timer, it will be 1, then it will immediately restart the timer. So the timer will keep on counting until it's preset. And this value will be used as a random value. Let's define that in TBox. Before doing the code, we will first create the resources, which consist in the timer instance and the tags associated to the timer. So I will in fact define two timers to have two random value. So I will make T random1, which is the name of my timer. I will associate a status tag, which is new digital tag T random1 st for status, no initialization, and a value, which is an analog tag of type 32 bits, unsigned, and it's T random1 value, val. Okay. I do that for two timers. I have defined the two timers with the associated status and value, which are then tags, status and value for both timers. Now I can do the script, and the script is, I have to insert a timer, so I just type timer, and if I'm not sure about the syntax for calling the function, I have an accelerator key which is F8, and this opens the list of all the functions. And if I have started typing timer, it will show me everything starting with timer. So I will use a single shot timer. So I select timer, I open the bracket, and the bracket is the argument I have to give to this function. The argument is the name of the timer, the condition for starting the timer, and the preset as a constant representing seconds, comma milliseconds. So the name of my timer is T random1. The condition for starting the timer is the inverted status of my timer, so it is not T random, it's not case sensitive, so you can type small or big letters, it doesn't matter, ST, and the preset, I would define a very small preset, for instance, 53 milliseconds. So this timer will permanently count between 0 and 53. By the way, a command can be put also at the end of a line, also starting with a single quote. So for instance, like auto-triggerable timer value 0.53. Let's do the same for the second timer. So I can just copy paste this, Control C, Control V, and I just changed random 1 with 2 and random 1 with 2, and I will change the preset from here, and I will say, let's say 42 milliseconds. Now I will compute my random value. The random value is a tag. If this tag exists, I can just type it. If I don't know its name, I can open the list of tags by pressing the accelerator key F7. This opens the list of tags. I select the tags. If it does not exist, I can create it. So let's create it. It's a new tag. It's called random1, and it's a float. Okay, okay. So I want in my flow to evaluate positively and negatively, not just increment. So I need to have negative values, but with my timer value, I have only positive value. So I will just take half of the value positive and half of the value negative, and for that I will take 27, which is about half of my total range, minus my timer value, T random1 val. Doing this, I will have a value which will vary between -26 and 27. Okay, but this is a little bit high for calculating a flow, incrementing value 26 or 27. I want to have a very little flow value. So this I will divide it by, okay, let's say 157.89. So I have made the calculation for you. So if I divide this by 157.89, I will have values returning between minus 0.64 to plus 0.171. Okay, so this is a good random value. Now, still, this will not work like it is here because of casting. And casting is very important when you associate variables together. So here I have a value, a constant, which is like a byte, because it's just 27. This value is a D word, which is a 32-bit unsigned value. And this one is a float, also called single. So let's see the rules when you associate different format of tags. This table is available in the manual Basic and Ladder for TBox. This table shows that when you the different possible format and the result of the internal calculation. So normally it will always use the highest format. So if I associate a word with a float, the result will be float. If I associate, for instance, a long with a 16-bit integer, the internal calculation will be long. So normally you always save. One exception, when you use constant. When you associate a constant with a tag, the constant is casted to the format of the tag. So if I go back to my code, this tag is a 32-bit unsigned. So this constant will be casted to unsigned. So I will never have negative values. So for that I will cast this into float, because at the end that is what I want to have. And for that we have casting function. And if I want to know what is the format of the function, I can just type C, then I press F8 to open the list of functions, and I have SNG. SNG because single is the other word for float. So I select this function and I select my constant, and now this in fact will be forced into float, so my internal calculation will be okay. This constant here is a float, but the internal calculation here is a float, so everything will be done in float. I will repeat that with a second random. Okay, I have created a random 2 and adapted the line. Let's send this to TBox at least to see our random value. So for this program water to be running, we need to declare it into main. Remember, the only program TBox knows is main. So everything has to be called from main. So I would just double click, insert a program, click on the left rail, click this file. I see the POU of my program here. I select water and I close the line. I compile, escape to leave, and I send. Sending is complete. So I can go to my list of tags, and what do I see? I see the value of the timer. So you see they are moving, and the result in random. So you see sometime positive, sometime negative, very small value. So those values, I will use them to generate the flow. Let's go back to the program and compute the flow. Okay, I will first insert a line of command, assigning random flows, and the flows will be assigned according to several conditions. So I will compute the flow when valve is active, because that's the condition for having a flow. Also, I will compute the flow each second, and for this I have a system variable which is called tick second, which varies each second from 0 to 1. So I will use both transitions to compute the flow. To use transition in BASIC, I have a function called trigger pos and trigger neg. It's the equivalent in the ladder to positive edge contact or negative edge contact. In BASIC, we have trigger pos and trigger neg. So I can just type if. You see that when I type a text which corresponds to a keyword, it turns in blue. Then I have my trigger. If I don't remember the name, I can press F8 and I see my function, and I can see trigger neg, trigger pos. So if trigger pos, I have to put a tag. It can be an expression or a tag. I can press F7 if I don't know the name of the tag, and I select the tag. So you can either work with the functions or just type, or trigger neg. When it is recognized as a keyword, it turns blue, and here tick sec. So I have two conditions: positive edge changing, negative edge changing. So it corresponds to each second. Then I compute the flow if the valve is 1. So if valve 1 equal 1, and then I will calculate the flow. But I have to define a range. I will compute the flow if it is included into a value between 1.5 and 4.5 cubic meter, for instance. So I have to put a new condition: if flow 1 bigger than 1.5 and flow 1 smaller than 4.5. And I have to include brackets between all the if condition. Then my flow will be the current flow plus the random value. Note that you can put space or no space, capital letters, small letters, it doesn't make any difference. Now, if I am not in the range 1.5, 4.5, then I will assign a constant to my flow. For instance, 3.297, which is about in the middle between 1.5 and 4.5. And this ends my flow computation. Now, if my valve is not active, then I have no flow. Then flow should be 0. Else, flow 1 equals 0. And this ends the code for valve 1, and I will repeat the code for valve 1 and for valve 2 and valve 3, and you can just copy paste and change the name of the tags. I have done a copy paste of valve 1, and I have just updated the ranges and the constant value. So I have to define a last end if to close the first if condition. Next part will be activating the valve. So I put a command. To activate the valves, I will use periodic events. Remember, we have used periodic events already for sending SMS, email, and files. We will use a periodic event to just activate, deactivate the valve. Let's say each X minutes, each valve will be activated, deactivated with different period. So let's say, for instance, valve 1 each 2 minutes, valve 2 each 3 minutes, and valve 3 each 5 minutes. So I create event, add periodic event, the tag does not exist, then I create the tag, new tag, it's a digital tag, I call it event 2 minute. I initialize it to 0, okay, okay. The period is 2 minutes, okay. I repeat the operation with event 3 minute and event 5 minutes, new tag, digital, event 3 minutes, okay, okay, period 3, and new tag, digital, event 5 minute, okay, okay, and the period here is 5. So I can go back to the code water, and in the code water I will, if trigger pause, I can press F7 to open the list of tags, my event 2 minutes, so each 2 minutes the tag will change to 1, and when it changes I will do then valve 1 equal not valve 1. So I just invert the valve 1. Note that if you put the statement in the same line as the if, you don't have to put end if. I can copy paste this line twice, and if I have event each 3 minutes I will activate valve 2, and the valve 3 will be activated based on the event on 5 minutes. That's it for the valve. Then we have to activate the pump. So the pump will be activated according to the level in the water tank. So F7 to select the tanks. I select my water tanks for simulation. Is smaller or equal, let's say, than 10%. Then pump equal 1. And if the same water tank smaller equal than 100, then I stop the pump. Then we have to fill and empty the tank. So to fill the tank we will just use a constant when the pump is 1, and to empty it will be emptied with the flows. So to fill, empty the tank. So once again we will base this on the tick second. So I can just copy paste this line here. So we will fill and empty the tank at the same rhythm as with the flow based on the second. So if pump equal 1, then I have to fill, and I will fill with a constant. So water tank will be the current water tank level plus, let's say, 5%. And this ends. And to empty, the water tank will be the current value of the water tank minus all the flows. Flow 1, flow 2, flow 3, and to empty not too fast I will divide this by 5. And this ends our basic code for simulating a water process. Let's test this in TBox. So we will send it. Remember that everything has to be called from main, but the program is already called from main when we tested the random value. So we can send from here. TBox has restarted, so let's take a look to the tags. The random value we had seen already. Let's take a look to the valves and the flow. The valve at the moment, valve 2 and 3 are active, which means that I should have a flow 2 and 3 computed effectively. I can force the valve if I want. So the valve is just an output, so I can just press F4, 1, and I force the valve 1 also. So I can see whether the flow is also computed. Yes, it is. If I look to the water tank, so now the water it's emptying at the moment, and when it will be below 10, it will start filling up. Effectively, it does fill up and emptying at the same time. So if I force the stop of the valve, I can just by pressing minus on the digital tag, it will fill much faster. And when it will be filled, it will stay filled without moving. I activate the valve, it starts emptying. Now let's consider data logging, because the simulation here, we want to record it so that we are able to trace the filling, the emptying of the tank and the flows. So we need to make sure that all this data is recorded into data logging. So in chronologies we have already declared the pump and the valves, and in the sampling table we have the flows already. I just would like to change the period in order to display something faster. But because those sampling tables are used in the report, if you remember, so they need to have the same period. So I would like to change it to 5 seconds, but I will need first to change the existing one to 5 seconds too. So my flow to 5 seconds with exactly the same size. And I will add my water tank exactly with the same average, the same size and the same period of 5 seconds. So let's send this to TBox, wait a little bit and see the result. A few minutes have passed since we have sent the program, so let's take a look into the different historical data. So remember, you do communication, retrieve from TBox, and you can access the chronologies and the sampling table. Let's first take a look to the digital chronologies, in which we have the valve activity and the pump. So we see when the valve was activated and deactivated. Corresponding to this, we should have flows. So the flows are in sampling table. So communication, retrieve, sampling tables. The flow 1 is the sampling table number 4. So I select sample table number 4, and I see, corresponding to the valve stopped, I see no flow. And when the valve is active, I have a flow between 1.5 and 4.5 cubic meters. The same for flow 2, for instance. Retrieve, sampling tables. Flow 2 is the table 5, and I have the same data when the valve is active. And my water tank, which will be filled and emptying. So communication, retrieve, sampling table, it's the ID number 7, sampling table 7, and I can see my value incrementing, decrementing between 10% and 100%. Okay, this later in the videos we will define that into an HTML page into a chart. This ends this introduction on basic program. Let's take a look now to the questionnaire. As usual, use the same application. Create a tag water tank of type float. Create 2 timer instances with their respective status digital tag and value dword. Create a POU program you name water and select its language as basic. Create 3 tags for the periodic events and create 3 periodic events with a period of 2 minutes, 3 minutes and 5 minutes. create the basic script as you have seen in the video. You can use F7 to open the list of tags, or type the tag name if you know it. You can use F8 to open the list of function, or type its name if you know it. Check the syntax of the keywords by looking to its color, must be blue. Add water tank in sampling tables. Type average 672 samples, period 5 seconds. Update existing sampling tables with a period of 5 seconds and keep 672 samples to avoid problems with the report, as those tags are already defined in the report. Send the application to TBox and check the result. Retrieve the digital chronology that we can see valve and pump activity. Save it and send it to us. Retrieve the sampling table flow 1 and water tank. Save it also and send it to us. And send us the whole application. Good luck.